So let's get started with concept of Droop characteristic. You will be getting Droop characteristic question both in power system and synchronous machine. This deals with sharing of load when two parallel generators are acting. It talks about sharing of load, how much load would be allocated to a particular generator. Fine. So it depends upon a very simple logic. Let's say you have a load frequency characteristic. So load frequency characteristic of a synchronous machine is something like this. Okay, negatively linear. On x-axis you have PD, that is power demand, and on y-axis frequency is there, which means what, 120 f by p is nothing but speed. Okay, so as power demand increases, frequency drops down, speed drops down. Okay, that's why it is negatively related. So what will be the thing? No, here you will be having to apply the concept of similar triangles. For example, this one is F no load and this is nothing but P rated. Okay, that is P full load. You will be having the information about F no load and P full load. You will be asked to find out, you will be given some P, let's say there is some P and there is a so let's say two generators are acting in parallel. So whenever there is a load sharing, there will be one constant operating frequency. At that frequency there will be some P1, there will be some P2. Okay, there will be some power P1, some load shared by P1 and some load shared by P2. But then what I want to note here is the frequency at which they'll be operating will be same. They can have different F frequency at no loads also and different power demand. So PD full load can be different. So what I'm trying to tell is basically P full load 1, P full load 2 will be there. Then frequency no load 1 will be there, frequency no load 2 will be there. But when there is a condition of load sharing, at that point this rest all will be different, but frequency at which they'll be operating will be same. Okay, when they'll be acting parallel and load would be shared, F is going to be same at which they are operating, and respectively you will get some P1 and P2, load shared by P1 and P2. Fine. So we'll see how do we calculate it quickly. Now what will happen is, firstly we will draw characteristic of F no load 1 and P full load 1. Okay, with that we'll get one straight line. Okay, with that we'll get one straight line, that is F no load 1 and P full load 1. Okay, F no load 1 and P full load 1. Similarly, for other one also we will be having information about F no load 2 and P full load 2. Okay, P full load 2. Then now since they are operating parallel, the frequency at which they are operating will be same. Okay, so this is nothing but some F, this is nothing but some F, and this will be some P2 and this will be some P1. Now clearly we can see that we can apply an equation of okay, let me tell you. Okay, there will be some one more thing will be there. There will be some F full load also, like for example, as there is F no load, there will be some F full load also, F full load 1 and F full load 2. Okay, so now what we can do is we can apply the concept of similar triangle, can't we? Definitely, right? We can apply concept of similar triangle. What we can do is we can do, one is this triangle and another one is this particular triangle. Correct, no? One triangle will be simply this. Okay, one triangle will be simply this, another triangle will be the bigger one. That is it, right? That is it. With that particular concept, what we can understand is we will get what, F no load minus F upon F no load minus F full load. This thing is equal to nothing but P1 upon, let's say, P rated. Correct. With that we can get equation for P1. Similarly we'll get equation for P2. Once that equation will get from two similar triangles, what we know in question, you will be given how much total load is there. Okay, and if no load 1, no load 2 will be given. If nothing is given, we'll take 50 hertz as default. Okay, and usually one more thing to note is, when no information about F no load 1 and F no load 2 is given, at that point we will consider some characteristic like this. We'll consider that F no load is going to be same. Okay, we'll not take that F no load is different, rather we'll take F no load is going to be the same thing. Fine. So yeah, now with that what will happen is, if nothing is given, this both will start from this very point. So this one variable will actually reduce. Since it is same value, it will be F no load at both places. So whole concept is dealing about just some 5 to 6 formula. With that you will be able to get every particular problem from this very concept, from this same similar triangle concept. Okay, so this 3 formulas are done from the similar triangle concept. Then droop, sometimes they can give you droop. So percentage droop is nothing but F no load minus F full load upon F full load into 100. Okay, that is percentage droop. From here you can find out relationship between no load and full load, and sometimes no load to full load regulation is given. No load to full load percentage regulation would be given. In that case what it means is, F full load is F no load into 1 minus percentage regulation. Okay, that will be using in questions majorly. And the last one, which is not a formula technically but which can be used, we have seen that P is nothing but F no load minus F upon F no load minus F full load. We have also seen that F full load is nothing but F no load into 1 minus percentage regulation. So F no load minus F full load is what? F no load minus F no load plus F no load into percentage regulation, right? That comes out to be F no load into regulation. So with this, now quickly we'll solve the we have understood the concept, we have understood what to be done when percentage regulation is given from no load to full load. We understood what is droop. Droop is nothing but F no load minus full load upon F full load. We have understood how power sharing is there, what to take when no F no load is given, and so on. Fine, now let's try to apply them on the concept. Okay, so concept of droop, a 50 Hz synchronous generator on a droop control delivering इतना ठीक है, इतना दे दिया है. Then it is load is increased. Please pause the videos and look at problem once. Okay, that will help you to understand the question in a better way. Here there is nothing. Y equals to k minus mx wala concept is there. Two informations are given. You will find line equation and then substitute third one and find the value. Here there is given speed regulation, so you will get the relation that F full load is F no load into 1 minus percentage regulation. That's the one thing. And then here F no load, no information is given, so we will take it to be 50. Okay, P1 plus P2 is given, and then F no load 1, 2 is given. Then straight away we will substitute them in P1, P2. With that you have so this will be constant only, right? This will be constant for both, since this is same, everything is same. So what we'll get is, you will try to find out this particular value. Once you find out this particular value, you will substitute in whichever power equation you need to find, and you will find out the respective power. Okay, you can pause this and you can try this once. With this we can conclude this particular session on droop characteristic. Thank you.